Sir, kindly unmute yourself, sir. Only you. I have done mute all for.
Okay.
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 Some background noise is coming that side.
Okay. Okay. You have muted again, ma'am.
Now it's no, sir. For you.
Okay. Maybe sometimes in Microsoft Teams, due to the huge number of participants, automatically it will be muted sometimes. Okay.
Some background noise is coming. That's why I have done mute all.
Okay.
No, it's not coming. me, sir?
Yes, madam.
Yeah. Okay. Some roadside. Your house is in the main road, sir. Some vehicle sound is coming.
Yeah, backside we have. It's not in the main road. We
Okay.
have quarters like stuff where
Okay.
backside of me we have a road which connects to the
Road.
main. So we
Main
have
road.
some vehicles. Yeah.
Some vehicle sound is coming frequently.
Not exactly like quarters. Most of our university people, they purchase the land and they stay here. Independent one, but most of them
Okay.
are Karan University employees.
Karana University members.
Yeah,
Okay, sir.
employees.
Super. Okay, sir. Shall we start, sir?
Yeah, sure, ma'am, sure.
Good morning. A warm welcome to all the participants. We are entering into the fourth day of faculty development program on artificial intelligence for robotics. Today we have three different diversified topics. The first topic is about deep learning techniques. Will be handled by Dr. Jude Hammond from Caronia University. Second topic is threat management by Dr. Ilamurugan sir. And third one is from humanoid robots by our own institution, a person from own institution. And the first topic will be handled by Dr. Uh, he is associate professor in the Department of ECE, Caronia University, Coimbatore. And Dr. Jude Hammond received his BE degree in ECE from Bharatiyar University in 2002, ME degree in Communication Systems from Anna University in 2006, and PhD from Caronia University in 2013. His research areas include computational intelligence and image processing. He has authored more than 130 research papers in indexed international journals and Scopus indexed international conferences. His cumulative impact factor is more than 175. He has published 36 books with reputed publishers such as Elsevier, Springer, and Eco. He has been serving as associate editor, scientific editor of FA indexed international journals such as Journal of Intelligent and Control Systems, Mathematical Problems in Engineering, IET Quantum Communication and DINA. He serves as an editorial board member, guest editor of many journals with leading publishers such as Elsevier. Mute all கொடுத்துட்டே இருங்க. He serves as an editorial board member, guest editor of many journals with leading publishers such as Elsevier, Soft Computing Letters, Springer, Multidimensional Systems and Physical Sensing, SN Computer Science, Sensing and Imaging, and InterScience, IJAIP, IJICT, IJCVR, IJBET. He is the series editor of a biomedical engineering book series in Elsevier and robotics and healthcare book series with the CRC Press. He also serves as consulting editor with the Elsevier publishers. He has received a project grant with 35,000 UK pound from Government of UK with collaborators from University of Westminster, UK. He has also completed one funded research project from CSIR, Government of India, and one ongoing funded project from DST, Government of India. He also serves as the research scientist of Computational Intelligence and Information Systems Lab, Argentina. And Lapisco Research Lab, Brazil, RIADA Lab, Tunisia, and a Research Center for Applied Intelligence, University of Croatia, Romania. He has been also organizing committee member of several international conferences across the globe, such as Portugal, Romania, UK, Egypt, China, etc. He has delivered more than 100 keynote talks, invited lectures in international conferences and workshops. He holds professional membership with IEEE Technical Committee on Neural Networks and IEEE Technical Committee on Soft Computing. Now I cordially invite Dr. Jude Hammond to take over this session. Over to you, sir.
Thank you. Thank you, madam. Thank you for your introduction. I thank Dr. Brindha and the organizing team behind this workshop for inviting me, otherwise for having the trust on me to share my expertise today for all the benefits of all the participants. Right? Participants, I know this is the fag end of the workshop. You have been attending this workshop for the past maybe 4 or 5 days, and you might be tired, right? I do not know about your situation, but sometimes, right, some information which we gather across the workshop or seminars which we are attending will definitely be useful for our research career, right? So I kindly request you to pay attention for the next 1.5 hours. Maybe the time is now 9:40. Maybe 1 hour 15 minutes or 20 minutes. Maybe I will be having a discussion with you. Then we can have a question answer session also, right? So that it will be always beneficial for you. Let us go to the PowerPoint slide directly. Madam, is my screen visible?
Yes, sir. Yes, sir.
Madam, is there, I think the mic is automatically muted sometimes. So if there is any issues, you can call me over my phone.
Yes, sir.
So
Yes,
that
sir. Definitely, sir.
yeah.
I will take it, sir.
So that's an thank you, madam. It's an interesting workshop or FDP, I should say. Artificial intelligence is ruling the world, right? And very soon it is going to completely take over the world. That is what the researchers and the scientists were talking about. And when you take artificial intelligence, you have different branches or subsections with artificial intelligence, right? You have computer vision, you have natural language processing, you have robotics and machine learning. All are some subsections which will be definitely going to have the final artificial intelligent machine to be a reality in this world, right? So that's a very good workshop or a concept from where we can learn many things, right? So one subsection is what I am going to concentrate in this morning, right? And that is all about machine learning techniques, and more specifically, I'm going to talk about deep learning techniques. I'm sure most of you might be from the background of computing or ECE, who might have got some idea on what these things are all about, right? I do not know whether you are a beginner or an intermediate stage person, but whatever it may be, right? The information which I'm going to deliver will be catering the needs of all the participants. So the topic I have chosen is why deep learning over traditional machine learning techniques, a practical introspection, right? In machine learning, I'm going to specifically talk about deep learning, which is one of the focal points of this workshop. So this is all about me, right? Madam gave me a very good introduction, right? So whenever I have a webinar, or maybe now the webinar is very frequent, every day I have a talk, but whenever I go for a face-to-face session, maybe with a gap of 1 month or 2 months, I go back and check the slide, right? I always have this slide with me, which act as a self-evaluatory tool for me, right? I check how I am going to or how I am proceeding in my research career, right? These are some of the aspects which I have in my PPT slide. So I will check if there is any changes in the slide. If there is no change in the slide, right, then what it indicates is I was not doing any work for the past 1 month or 2 months. So this is the way how we have to improve ourselves in the research career. Attending workshop is very good. Gathering knowledge is very good, but how we put that in the practice, that is very, very, very important. If we are not putting anything in the practice, again, we will be attending workshops throughout our career, right? So as a participant, I also advise, if you are following my webinars, you might be knowing that I always advise my participants to have a one slide like this. So it will be useful for you to have a self-evaluation for you, right? So you can check and you can think how you are going to move further for the next 3 months or the next 6 months and so on. So these are some of the points. Maybe you can have some details from here, but there are also other points which you can include. Publications, you have the projects, the editorial board assignments you will have, and there are many outside labs looking for researchers like us. If we are interested, we can join with them, but we need to work with them and go for some publications or patents or projects or something like that. Now, this is the agenda for the today's session. Need for deep learning approaches. Right? If you ask any computing engineer or any data scientist or anyone working with the concept of machine learning or deep learning, they always talk about deep learning, but why? The question is why. If you ask them why, I know 50% of them will not be able to say what is the speciality of deep learning. They just say the world is going after deep learning, we are also going. Right? So better understanding of why we go for deep learning is very, very important to make sure we can have some contribution on our own in the deep learning. And specifically, the second bullet will be the type of the neural network or the deep learning network, which we are going to see is the convolutional neural networks. This is one of the preliminary networks and mostly used for image based applications, right? If you Google down, I am sure you will get thousands of deep learning approaches, but my concentration for the next 1.5 hours, the time is only 1.5 hours. So I have taken convolution neural networks. So most of you may be working on it or may be planning to work in deep learning. So for them, it will be an ideal catalyst. And then we have an advanced representation of CNN, which we call it as transfer learning, that we will discuss. And finally, I'll give you one application of CNN with respect to the current pandemic situation. All right, how we can use deep learning for COVID-19 detection. Some of my own research works, which have been recently published, I will share with you, right? And finally, I'll give you some open research problems. If you are a research scholar, maybe you can take that, or if you are an academician, you can try giving to your student. And finally, we can have a question answer session. Right? Question answer session is very, very important because whatever I am talking is from my mind. I have a flow and I give you the information content, but your expectation may be something different. Right? At that time, you can make use of this Q&A session to get your doubts clear. Right. So now we will go into the first one, need for deep learning approaches. Right. Machine learning is very, very important to make a machine intelligent. To make a machine intelligent, we give several data and make the machine learn from the past experiences. All those methods comes under the category of machine learning techniques. But there are many machine learning techniques, but the commonly used machine learning technique for most of the application is artificial neural networks. Right? They prove to be at least experimentally more successful than other machine learning approaches. So maybe if you look at the timeline, maybe 25 years back, there were much grace towards artificial neural networks. Now what happens is people are switching towards deep learning approaches. Right? So we will see why and how. The prerequisite is that if you go for a deep learning based implementation or anything, you must have a basic knowledge on artificial neural networks. Some of my research scholars used to come to me and tell, sir, can I try this with deep learning? The next question immediately I ask them is, how much do you know on the basic concepts of artificial neural networks? Right? So the foundation of deep learning is seen in artificial neural networks. If you are very good in artificial neural networks, you can jump into the deep learning concepts. If not, if you think that you are not that strong, either in a theoretical way or in a practical way, I will kindly request you to have a look at artificial neural networks before putting your hands in the implementation aspects of deep learning concepts. Right? Deep learning techniques use the neural architectures only. Without ANN, it is not that easy to understand the concept. But anyway, if you have at least some idea, I'm sure you can grasp the information what I'm going to deliver. So this is the history of deep learning, right? Or otherwise, I should say evolution of deep learning, how it evolved. So in 1940, if you carefully look at the concepts, we have the method of electronic brain, Michelopit's model. We say Michelopit's model. It was the first seed for what today's deep learning is all about. Right? They created something equivalent to a human brain, not the complete network, a single part of it, and they thought that it will be useful for any classification or segmentation or any pattern recognition application. It also worked. So in later in 1950, Rosenblatt came and he developed a bit more complex network, which we call it as perceptron, right? And perceptron after perceptron, we had Adeline, which is called as adaptive linear network, and many neural networks were framed in those periods. But the common feature of all the neural networks in those period is all are single layer networks. I hope you must be knowing about what do you mean by layer. Layer is a column-wise arrangement of neurons. Right? So in the brain, it is arranged in a chaotic way, but when you go for an implementation, we have a column-wise arrangement of neurons as different layers. In 1970, they thought these single layer networks are going to be the best among artificial neural networks. But in 1970, they faced a problem which is called as XR problem, or we call it as linear classification problem. Down you can see the chart just below the Minsky and the Papert figures. You can see the chart. One is the AND gate or the OR gate, the first one, where it is easily separable. But when you go for the second one, the oval shaped diagram, some data are arranged in such a way that you cannot separate them with a single line or a single layer. So 1970, the complete work on AI or artificial neural networks stopped. And from 1970 till 1990, maybe some years, something like that, we call it as AI winter, where no work was carried out. Right. Again in 1990, Rumelhart and some other people came together and they formed or they overcome this drawback, right, by forming a multi-layer network. Layer, layer, layer. This word is the key word for deep learning approach, right? Single layer, now we go for the multi-layer artificial neural networks. XR problem is solved and it was very useful, right? It was very useful for all pattern recognition applications. And this multi-layer network, which we call it as backpropagation neural network, evolved into a process what is called as deep neural network. Right? So my request for you on this slide is, when you frame something new, don't think it should be 100% perfect. If you observe that perceptron has some drawback, Adeline has some drawback, that BPN came, BPN has some drawback, SVM came, SVM has drawback, deep neural network came, and deep neural networks also has some drawback. Deep learning also has some drawback. So it is like an evolution, but we should not be scared of finding anything new. That is the main objective of the research community. You gather knowledge from workshops like this, try to put into practice and develop some contribution or some model on your own. So that's why how these concepts are evolved. Now we are in the state of deep neural network, and research papers or journal editors, everyone are looking for pattern recognition applications using deep learning. I am not very sure that if you still work with ANN and try to publish a paper, I am not very sure whether it will be accepted, right? Because the world has changed. Now, why we have gone for deep learning when we have artificial neural networks, right? Why multi-layer BPN is not good enough in comparison to your deep learning approach. So basically, you must understand what do you mean by deep learning, why they have given the word deep learning. If you look at the phrase deep learning, we have two words here. One is the deep, the other one is the learning. We will see what is meant by deep. The word deep corresponds to more layers. First we had single layer network, BPN came with multi-layer network, and now I am saying that any deep learning or deep neural network structure or method is going to have more layers than your backpropagation neural network. That's why they have given the word deep for this specific topic. Right now we'll see what is this deep. You can look at two architectures. One on my left hand side, which is the conventional BPN. you can see you can have one input layer, you have one output layer, and you have a hidden layer, a normal architecture. But when you look at the diagram on the right hand side, you can find that you have one input layer, one output layer, and there are more hidden layers. Right? This is just a sample I am showing you. There are more hidden layers, right? So first architecture, I'm going to call it as ANN. The second architecture, I'm going to call it as deep neural network, right? But what is the difference? Only in the number of layers. Now you can ask me a question, right? Already we have BPN and I told you that it is a multi-layer. Multi means many, any number of layers you can have. Then why should we go for a new architecture? Why can't we name the same as BPN, right? By including many layers on the diagram on my left hand side. Can't we have ANN with multiple layers? BPN is already there. Then why should we go for something like deep neural network? Right? So this is the question which may come to your mind, right? But the answer, we have an answer for that also, right? The first point you have to understand is the main reason for increasing the layers in a specific network is to increase the accuracy, right? So you will be confident or sure enough to increase the number of layers. You don't have doubt on that.
Excuse me,
Okay,
sir.
I need. Yes, madam.
Yes. Yes, yes. No, the voice problem.
Yes, madam. Any problem?
Sir, you can press. No, sir. No, sir. Now it's corrected.
Okay. Okay. So more number of layers means high accuracy, right? The number of layers is going to determine, it is one of the factor to determine the accuracy. Now you are very sure that you need more layers. But when you go for increasing the layers in a conventional ANN, or you can say BPN, if you are increasing the hidden layers in a conventional BPN, and if you train again that same network using the conventional BPN algorithm, then your accuracy may not be that high, or your BPN will not be successful enough. You are not going to get much benefit in terms of the performance measures of the pattern recognition application. This is the main drawback with BPN. If you look at the research works maybe 10 years back or 15 years back, people were very interested towards finding the number of hidden layers in a BPN architecture, right? How many should I have? Either 3 or 4 or 5, depending upon their application, they try to find out that. But nowadays what happens is 1, 2, 3, 4, 5 doesn't going to work for you. We need to have more number of layers in terms of hundreds layers, right? Hundreds of layers to make sure your accuracy should be high. That's why we say that when you go for BPN, you restrict with maximum 1 to hidden layers and you get a sufficient accuracy. But if you try to increase the number of layers in a normal BPN architecture and training algorithm, then your system will not work, right? That's why when you go for deep learning approaches, we have a different set of learning process. You take convolutional neural networks, the learning process is not same as what we have in a normal BPN architecture. So this statement is not mine. You can refer this specific link where they have given plenty of validations or the reasons why a BPN with more layers is not going to be ideal choice. Right? Now you will understand the meaning of this word deep learning. Deep means more number of layers in architecture. Learning in the sense a different training algorithm must be used for your deep neural networks. Second aspect or second need, why should we go for deep learning? First one is we talked about the architecture and algorithm point of view. We came to a conclusion for better accuracy. You need to have a better layered architecture. Second one is in terms of the application. Right? Most of the artificial neural networks are used for pattern recognition applications. I'm sure you must be knowing about what is meant by pattern recognition application, right? Determining whether it's a cow or a dog, or whether it's an aeroplane or a bird, right? Any such classification or segmentation, anything comes under the category of pattern recognition applications. Say, for example, we take a simple case study of this digit recognition, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So I can easily say this. Now I want a machine to do that. If I have an artificial neural network inside that machine, then this will be the block diagram for your process, right? I'm sure more than 95% of you sitting on the other side will be or would have used this diagram. You have the database input, you have the pre-processing, you have the feature extraction, and also you have the recognition. And our artificial neural network will come and sit in the recognition process, right? This is a normal conventional step anyone can say. But when you go for deep learning approaches, right? When I say deep learning approaches, all the methods which comes under this category, right? There is a small change. There is a small change. You do not have a separate feature extraction block. In other words, you do not have a manual feature extraction process. Right? In a normal ANN, what I used to do is I take an image or any data, and from that image, I extract some features. I select some features. Say, for example, what is a feature? I am here, someone else on the other side maybe sitting there. If I want to categorize myself and that specific person, I need to find the characteristic features, unique features, which is going to differentiate myself and the other person. Say, for example, if I take color of the hair, right, color of the hair, my hair color is still black in color, and I hope the other person also sometimes may have black in color. Then how the machine is going to identify? That is a wrong feature. When you go for manual feature extraction, there is a high chance that you may choose a wrong feature. Instead, if you give the responsibility of feature extraction to the classifier itself or to the recognition system itself, then the performance will be much more better. Right? So this is the major difference between an artificial neural network and a deep learning approach. Always remember, there is no manual feature extraction. The system itself will find the features necessary for the classification or segmentation process. Right? So the question is why? What is the drawback with manual extraction of features? Why can't we have that? I have an ANN. I can have the extract features with me also. I can extract and give to the classifier. What wrong in that? Right. First one is when you try to extract features, you will need the help of an expert because you do not know what specific feature is unique for person A and B. Right? Say, for example, you take a professor sitting on the other side. I have never seen him. Right? But a person who know me and also that person will be the ideal one who will be able to find out what are the characteristic features between myself and the specific person. If no such person is available, then how can we extract the correct features? Right? And to be frank, most of the practical applications lack this expertise. That's why we have a separate area called as expert systems, how to generate expert knowledge. Right? So if you don't have an expertise, there is a high chance the features which you are going to extract may be wrong. Wrong in the sense it may be irrelevant or it may be common to both the people. So what happens? These features will create a confusion in the mind of the machine and it will give very less accurate results. Right? That's why manual feature extraction should be always avoided. Even you would have faced this difficulty whenever you're doing some application, you would have scratched your head to find out what specific features I should make use of for my application. It's still a very big research area. Feature extraction and selection is another big research area where till now no concrete evidence is available for any specific application. But in deep learning, you do not have this problem at all. Right? The system itself will take care of that specific job. I will validate my statement with a simple case study. We will take the same digit recognition and the features, manual features, which I'm going to use in the network or the system are horizontal lines, vertical lines, and small circles. Right? Now we will see how these features, whether they are good or bad. Right? So this is the digit number system. And first we will take the vertical lines. So where do you have vertical lines? Digit 1 has a vertical line, right? So if this is the only digit with this vertical line, then it is a very good feature. So system, whenever it sees a vertical line or a vertical line as input, it will easily recognize that input data is 1. But unfortunately, what happens? 4 also has a vertical line. 9 also has a vertical line. 7 also may have a vertical line. There are more than one digit with the same vertical lines. Okay, now you come to the horizontal lines, right? Where do you have horizontal line? 0 may have a horizontal line, right? When you write 0, you may write 0 in infinite number of ways. There is a chance, right? Then you will have 3, a portion may look like a horizontal line. 4 may have a horizontal line. 5 has a horizontal line. 7 has a horizontal line. All digits you can write in many ways. So there is a high chance that our data is not um, that much accurate, right? At least in a human perception. So in the same way, there can be more than one digit with the same type of features. Now you take small circles. Where do you have 2 has, 6 has, 9 has, 8 has, more than one digit. Now what happens is the machine will get confused and it may think that instead of 6, it may recognize as 9. Instead of 9, it may recognize as 2, and your system fails. That's why artificial neural networks, which is completely dependent on manual feature extraction, most of the time are not able to give good results. Till the development of deep learning, we were thinking that ANN is going to be the best. But when a change happened, when one person's thought, it is Professor Hinton, who is called as the father of deep learning, right? A Canadian. In his team, one person took the thought that there is a chance that we can make some changes like this, and now the entire world is going towards that, right? So these are the two important necessities for the deep learning approach to be used in a pattern recognition application. Remember, first in terms of architecture, layer, the second in terms of the learning, deep learning, the second word learning, where your training algorithm is going to be different from what we have in ANN, and the third one is in terms of application, where there is no manual feature extraction. Right? As an editor, when I look my login for the paper submitted by the authors, to be frank, 80% of the time I will see a feature extraction block given in the block diagram or methodology part of the deep learning structure, right? So the reason is, with the advancement of software technology, maybe Python or MATLAB, people are very convenient in getting the results, right? Just drop down in MATLAB 2018, we have the option for deep learning, CNN, autoencoder, deep belief network, everything is available. Drop down, you get the result, but you do not know what is happening in the background. So when you write a research paper, you think the same block diagram is enough. Just AN is replaced by deep learning. No, that is what you think and you write a paper. But when we screen in the initial stages, there is a high chance that your paper will get rejected. Right? So never ever make simple mistakes like this. Okay. So once we have an idea of why we should go for deep learning, now we will see what are the different types of deep learning approaches available. This is the complete architecture of machine learning, and this specific box which I'm highlighting now is the deep learning block or the methods in the deep learning architectures, right? These are some of the deep learning architectures which are widely used for many applications, right? So I have given only few, but if you Google down now, you will see hundreds of deep learning architectures, because people think based on the background information they have got, they think and try to make changes in the deep learning networks so that a better performance or a better system can be obtained. So maybe if you are a new or if you want to try something, you can Google some of these methods in the net and get some details. Among this, I am going to concentrate on convolutional neural network, which is the commonly used one. You take any research papers on deep learning, at least in pattern recognition perception, you can see CNN. So if you have a better idea on what is CNN is all about, people take results, but they are unable to give out what is the inference from the results, right? Why this method is better than this method? Because they do not have a background information on DC and, right? So that's what we are going to see now. So need for CNN, as we saw in the first slide, we saw a complete evolution of artificial neural networks to deep learning methods. In the same way, CNN also has a primitive network. The first frame network is called as deep feed forward neural network, right? But it has a drawback. That's why CNN came into existence. We will see what is the drawback. Right, same, take the same case study of number recognition, and you are giving to a DFNN, the deep feed forward neural network, a data as 8, and you have trained that DFNN to identify whether the input digit is 8 or not 8. Right, so whenever you give an 8, look at the first one on my left hand side, an 8, the system says 100% it is an 8, that's fine. The second set, when you give a 5, it says it is not an 8. That's good. That's very good, right? But when you give this data, right, the second data, what happens? When I give the same 8, the same system 10 minutes back, the same DFNN, which 10 minutes back gave me the correct answer, now is getting confused. It says no idea. When I give 5, it is asking me, what is this? That means it is not able to recognize 8 or not an 8. What is the difference between these two? I don't find any difference, but there is an actual difference between the way in which this data is given. If you carefully observe, the digits or the region of interest, right, is present in the center of the image. The box you can consider as an image. It is present in the center of the image for the first set, but when you look at the second set, it is in the corner, bottom corner or the top corner. So your DFNN is sensitive to the position of the region of interest, right? You can say that it is highly sensitive. If there is a small change in the position of the data, then the system fails. Now, how can we solve this problem? You can tell me, sir, what I'm going to do is I'm going to train my 8 with all possible positions, right? Wherever you can find, you can write some 8 and you can give that system as input to the system. But remember, already our deep learning method is having more layers. More layers means computational complexity is high. Now, when computational complexity is high, and again you give more number of images, your system will hang. It is not ideal for it. Then you can argue again, no, I have the recent advancement in terms of graphic cards, the NVIDIA, the GPU, the parallel processor, and all those stuffs. I can maintain the time, I can manage the time. You can argue, but still my question is, if I am sitting, my name is Jude. If I am walking, my name is Jude. Just because I'm going to change the position, right? My name doesn't change. Then why do you need a system which is not able to say that my name is Jude irrespective of my position? Right? It doesn't make any sense. So you need a system or a method which can give the correct answer irrespective of the position of the data. Right, so this drawback was invented or discovered from this DFNN, and the researchers were looking for some solution. How can I have a complete machine which can identify the data irrespective of the position? The answer is convolution. Convolution. If you're from ECE background, I am very sure you should have learned about convolution in signals and systems. Not convolution. I'm not talking about CNN. I'm talking only about convolution. The solution is convolution. How? How can we solve this problem? So this specific information I have taken from Wikipedia, the correct definition for convolution, which says it is a mathematical operation on two functions, right? What are the two functions? F and G. F is my original image and G, for the time being, you can take it as a duplicate image, right? So when I convolve these two things, I am going to get an output which is going to be called as a modified version of one of the original function, right? Or you can say modified version of F, which is my original data or original image. What modification? What modification you can see? It is a translation effect. It is a translation effect. That means the data which is present in the center in the original image after convolution may be available in some different positions. Right? So this simple concept struck a specific team member of Professor Hinton, and he thought, why can't I go for convolution plus artificial neural network? And they removed the word A, they joined CNN, and the resultant is convolutional neural network. Don't think convolutional neural network is something new. It is just a hybrid method of two already existing methods. Normal convolution, when mixed with your normal artificial neural network, you will get the deep learning architecture. That's why I told you the concept of artificial neural network is very, very important. Right? Now we will see how this convolution is able to do this process, how it is going to create a modified version of images with different position of data. You take a simple image. You can see here a small boy sitting in the middle of the garden on the duck, right? Say, for example, a human being can easily recognize this as a child, this is a small boy. But if a machine want to recognize it, right, how it is going to recognize, right? How it is going to recognize? Take our CNN. So the CNN, the first C, the letter C corresponds to convolution. So there is a convolution process going on with this original input image, right? What happens at the convolution process? This is what is happening there. The original image is divided into many small images, right? Many small images. You can see 3, 6, 7, I think 77. There are 77 small sub images from the original big image, right? Now you can see that the body part of the child is available in more than one location in the sub image. If you see the sixth sub image, right, sixth small image, you can see the head is in the rightmost bottom corner. If you see in the eighth image, it is in the leftmost corner, right? And the head is somewhere in the top, some in the bottom, your hand is in there, your leg is in the middle, your leg is. So you can say that the convolution itself has the capability of dividing your original data into multiple small data where the possibility of the region of interest being available in more than one slide is very, very high. Right? So you need not supply an image with different positions of data. The system itself is going to do the same process. How do I do that? With the help of this specific term, right? If you are into image processing, I am sure that you must have learned about Roberts Previtt-Sobel operators, right? They are called as filters or masks or edge operators. These masks are nothing but the duplicate image which I told you in this slide. F is my original image. G is called as this mask or the operator. So involve these two things, I can have a complete splitting of my original image where I can see that the body portion of the child is available in more than one sub image. Now there's no necessity to train the network with new images where the child is in different positions. The system itself is taking care of that, so that the chance of accuracy of identifying that a child is sitting in the image is very, very high. Now we will go into convolutional neural network. So we have an idea of what is happening with the convolution process. Now we go into the convolution neural network, how the architecture looks like, right? You have an input image and we have a three-step process, right? Input image, then we have the concept of convolution, then we have the concept of max pooling, then we have the concept of fully connected neural network. That is nothing but a normal artificial neural network, or you can say normal backpropagation neural network. That's why I gave much emphasis when I talk about the evolution process. So before fully connected neural network, we have two additional process, which we call it as convolution and max pooling. And interestingly, you can call this as layers. Input image, then you have convolution layer, then you have max pooling layer, exactly how we had in artificial neural network, right? Then you have the fully connected neural network where again you will have some layers, input layer, hidden layer and output layers. But again, when you go for practical implementation, there is still an issue that how many layers I should have, right? How many convolution layers I should have, how many max pooling layers I should have. It's still a problem, but I will give you some solution at the end of this presentation also. First, we will see how the convolution process is going on, right? So take this image, take this dog image. I'm seeing a set of 3 dogs, a cute dogs. Now, human being can see the dog, but the computers, what happens is it cannot see the dogs, right? It can see only the pixel values or the intensity values behind the dogs, right? If you are good in image processing, you must be knowing about this, the pixel values or the intensity values, which are responsible for the appearance of this image. So now what we are going to do is we are going to play with numbers, the numbers what the computer see and determine the convolution output. Let us see how. Let us assume an input image of size 32 cross 32 cross 3, right? Now the machine is going to find out whether the object present in this image is dog or not. Now you take a situation, assume a situation where you are left in a dark room. Right now you are searching for an object in the dark room. What will you do? You will take a torchlight or a flashlight, go to the room and look for different positions of that room. Right? So when you lit your flashlight, what will happen? Not all the room will be shown to you. Only a specific portion of that room will be shown to you. Right? Now this situation can be compared with our situation. The entire image is equivalent to the entire dark room in which you are going to search. Your torchlight, which is useful for searching, is nothing but the function G, which is nothing but the filter or the mask, right? So when you overlap your F and G, or in other words, when you convolve F and G, or in other words, when you show the torchlight towards a specific portion of the room, what happens? A small portion of the room is visible. That is going to be called as the first subimage. Right? Subimage is smaller in size. In the same way, only one portion is visible to you. Right? So now what happens if you are unable to find that object, right, in that specific position, what will you do? You will search in another portion. Likewise, till you find the object, you are going to move your torchlight throughout your room. The same process is going on inside the convolution also, right? So what happens is that flashlight can be called as a filter or a mask, which is again going to be a small matrix, right? Small matrix, maybe the size 5 cross 5, or you can say 3 cross 3 or 4 cross 4. Anything is fine. That depends upon the user. Now this 5 cross 5 pixel is called as a filter or a mask or a kernel, right? It is related with image processing stuff. Now what you are going to do is you are going to overlap your filter on the image, right? You are going to show the torchlight on the specific portion of the room. So what do you mean by overlapping mathematically? It is nothing but multiplication and summation. Multiplication and summation. So a small portion 5 cross 5 image is taken and it is going to be fixed on the top leftmost corner first, right? Then you will get an answer. What answer you will get? The corresponding intensity values will be multiplied. Remember, this mask or filter is not an image, right? It is a simple matrix with very low values, right? So they will be multiplied and they will be added together. When you multiply and add together, what will be your answer? You will get a single value, right? Then what you are going to do, you are not able to find that object in that specific area. Now you move shift your location a bit. Again, another 5 cross 5 region will be overlapped. The filter remains the same, but the position in the image will vary. Now you will get another number. So if you keep on moving your mask over the image, you will get different numbers, single number. So if you are moving for 784 possible locations, right, then you will get 784 single numbers. which you can convert into a two-dimensional matrix. 784 single column, convert it into a two-dimensional matrix where you will get a 28 cross 28 size array. This is an example, right? So this 28 cross 28 is called as a single sub-image, right? Now, I want to have another sub-image. I am unable to find the object from that specific torchlight. What will I do? I go keep this torchlight, take another torchlight. When I take another torchlight, the clarity may be high. The size of the flash portion may be high, right? So the parameters may change. Then I will get the same process will be repeated. Then I will get another sub-image, right? So depending upon the number of filters you are using, you are going to get different small images. Now can you compare how the child's image is broken into different small sub-images? I'm sure you can do that. This is the mathematical illustration for that. This blue color is the original image where some values, these are some example values, is given there. Now this red color, take the first red color box, 3x3 box, which is the filter, right? So I'm just overlapping with the position of the one position of my original image. So the pixel values will be multiplied 0 into 1 plus 1 into 1 plus 0 into 1 plus 2 into minus 1. That process will go on. And finally, how many values I will get? A single value. That single value is given in the extreme right side of the screen, which is denoted by -4. Likewise, the same filter will be again overlapped on another region. I may get 2, 6, 0, 5, 8, -4, 0, 1, -1. So 9 locations were there. I was able to get 9 single numbers. When I convert into 2D matrix, I will get a 3x3 matrix. Now, if I take another filter and overlap on the image again, I will get another. So for visualization, you may get something like this. You have a car image. This is the original image, but this original image is divided into many small sub-images in the first layer of your convolution neural network. You can see there are 10 small rectangular boxes. So 10 sub-images you have got. What do you see in this each sub-images? No much information, but you can see some shades, some lines, some curves, right? Some variable intensity values that you can get. Now, the interesting aspect is each sub-image is called as a feature descriptor. Now, can you correlate with the statement which I gave in the initial introduction slide, need for deep learning approaches? I told you the feature extraction is done automatically, not manually, right? So this is one step, or we can say the convolution actually does the process of feature extraction. Right? Does the process of feature extraction. Each small box can be called as a feature. Right? Now we'll take this as an example for a first convolution layer output. Right? I have done one set of convolution process and I have got this output. Right? The filter is given here and this line is given here. Now I'm talking about an animal. Can you tell me what animal I'm talking about? Anybody want to take a guess? You can unmute and let me know. Anybody want to take a guess? What am I talking about? You may not, right? You may not, because this information is not sufficient to identify this is a tiger or a lion or a giraffe. Most of the animals will have this information, right? Actually, I was talking about the back portion of the mouse. Right? When I overlap my filter with my original image, this portion is visible for me, not the complete portion. What do I mean to say? The output from the first convolution layer is not sufficient for identification of the object, or I can say the information which I got from the first layer output are called as low-level features, from which you will not be able to identify the object. So what should you do? Do one more convolution. That's why I told you there is a problem. I do not know how many convolution layers should I have. do one more convolution. When you do more convolution, you can find that you will get higher level features. So more convolution means more layers. Now can you correlate it with the first information I gave you? More layers corresponds to more accuracy. So more the number of convolution layers you have, the better will be your object recognition capability also, right? Say for example, what are these higher level features? Maybe the paws of the cats, the claws of the eagles, the beaks of the birds, maybe called as higher level features. Or in terms of shapes, you can say that square. What is a square? Square is formed from four straight lines joined at 90 degree or some degree, right? So a single straight line may be output of one convolution layer. When you give that as input for the next convolution layer, there is a high chance that you will get the continuous region. So when you finally find a square, you may get at least some idea. Okay, it may be a box, or it may be a table or something which is in the shape of the square. This is how the machine, the CNN, is going to identify or recognize what object is there in your picture or in your image. Instead of myself extracting the features, it is going to extract the features on its own. Now, I have many convolution layers. You are good in convolution layer, fine. What's the second step? It is all about max pooling layer. Why should we go for max pooling layer? Now you can, I am not sure if you have observed the child sitting on the image diagram. We have split it into many small parts. You can find that the body portion of the child is available in more than one sub-image, but not in all sub-images. If you would have observed the first 6 or 7, it was without any portion of the child's information, right? That means that sub-image is not necessary for my further processing. When I finally give it to my fully connected layer network, it doesn't have any information. Already my network is going to be huge. Why should I again burden my network with an unwanted image? So what I can do is I can remove those sub-images which doesn't have any useful information. How do I find that? How mathematically is done? You do the convolution process, that is multiplication and addition, and whenever you find a smaller value, look at the rectangular box of the second diagram on the right hand side, you can find that the value is 0. Right? Whenever you find a value of 0, then you can easily identify there was a mismatch between the filter and the object. Right? All other values are 0, then multiplied with 0 is going to be always 0. So you can remove the sub-images which gave you a value of convolution value of 0. Right? So this is how we can identify whether this sub-image is useful or not. So we are going to reduce using the downsampling technique. This downsampling technique is called as max pooling. So max pooling, how can you do this downsampling? You can take and arrange 4 sub-images in a single quadrant. You can take 4 sub-images and arrange in a single quadrant. You can see the yellow color dots. These yellow color dots corresponds to the 4 sub-images. These yellow color dots corresponds to the 4 sub-images, among which the circled one is the one which with the highest possible value. Highest possible value means more information. So I am going to take it for my further processing, right? So 1:4 is chosen and the remaining 3 are eliminated. But this 1:4 is my choice. You can go for 1:2, 1:6. That is up to you. So max pooling just do the process of downsampling, nothing else. This further reduces the dimension of the data. Now you are going to give it to the fully connected layer or the artificial neural network. So you must have a thorough idea on the training process of normal neural network. It is a normal ANN with many layers which requires training as usual. How do you train the convolution neural network? Now you understood that you have convolution layer, you have max pooling, you have fully connected network, right? So how do we train that process? So we have a forward pass in which first The filter parameters are also called as weights are randomly initialized. In the normal neural network, you will have only the concept of weights between the hidden layers. But when you look at your convolutional neural network, you will have the filter parameters also. They are very, very, very important, right? Based on the filter parameter size, you are going to overlap. So when the filter parameter specification changes, it will also change. Right? If the clarity is good, you may find the object. If not, you may not be able to find the object. Right? So we have two set of parameters to be adjusted in CNN, which actually is the reason for the heavy computational complexity of CNN. Right? The filter parameters should be adjusted and also the weights. Both are randomly initialized in the first stage. Using these weight values, as we know, we find the convolution layers. Then repeat for many convolution layers. If you have more, then you go for the max pooling layer. Once you complete the max pooling layer, now you are going to pass on to the fully connected layer. But here you need to understand that your max pooling layer output is in the form of a 2D matrix, right? But your fully connected layer, I showed you a diagram where the first layer is in the form of a single column. So your 2D should be converted into a 1D dimension. Once you do this process using a flattening operation in Python language or anything, right, you can convert into a single layer, give it to the fully connected layer, where again you have hidden layers. That weights also should be adjusted. Right? How can we do that? Normal process, the stochastic gradient descent process, where your error value is determined based on the outputs and the targets. So you can have an idea that CNN also comes under the category of supervised machine learning approach. Right? Normally we go for cross entropy when you go for CNN, but your error also can be used. Now, based on the error, you are going to come back in the reverse pass. So in the reverse pass, your weights of the fully connected layer will be adjusted first using a mathematical equations and expressions are available. And then we go for adjusting the weights filter parameters. Once these two parameters are changed, again the forward pass will take the reverse pass and this iteration will keep on going. You must have a thorough idea on that. That's why I told you in the initial slide itself, try to have a good knowledge on artificial neural networks. You can refer some of my YouTube videos, which I delivered a talk in other institutions, right? Or you can refer this good book, Lauren Fawcett, where the B-pin algorithm is clearly explained. So this process is repeated for a specific number of iterations till your output is equal to target. That means your error or entropy is going to be the ideal value. Once trained, now you store your filter parameters and also your fully connected weights. With the help of these stored weights, you can again go for the testing process by giving a input image and you can identify whether it is a cat or a dog or a cow or whatever it may be. So this is a small mathematical step, maybe due to lack of time, I will just skip this. Mathematical steps are very, very important, right? Deep learning is all about computer science plus maths. People are very interested to go for deep learning, but they hardly show interest in studying or learning the mathematical concepts, right? It's very, very important. And research papers, when we look at the research papers submitted for our journals, first thing is we look at how much amount of mathematical equations are there in the paper, right? Engineering is all about maths, but deep learning papers hardly have any mathematical equations within them. The reason is all these mathematical equations which I am showing you now is available as a simple tool in the Python language. So why should they go for programming this? So they do not pay attention. That may not be necessary, but to make some changes, you must have a complete understanding on this mathematical equation. This is a simple filter and an input, and you will have an output, and your one overlapping process. Your output is shown as a combination of your normal multiplication and summation. Multiplication and summation. Convolution is all about that. So when you go for O11, O12, O21, O22, depending upon the number size of your filter, and this is the way how the filter parameters are adjusted, right? Your output layer is very close to your fully connected layer is very close to the error or the cross entropy function or the objective function. But your filter parameters are not very close to the objective function. So we have an indirect chain rule process of differentiation for the updating the filter parameters, right? Maybe you can go through these mathematical equations later. If you have any doubts, you can contact me at any point of time so that I can clear your doubts. So the formula for finding the updating the filter parameter is, you look at the left hand side of my screen. Dou L by dou F is equal to dou L by dou O into dou O by dou F. Dou L by dou O is the actual loss function differentiation with respect to the output value at the output layer. The other one is at the filter layer or at the convolution layer. We make use of chain rule of differentiation, right? Whenever you study deep learning or artificial neural network, you will have differentiation, right? The reason is we want to make the error equal to 0. Right? To make the error equal to 0, suppose if your values get trapped in a constant value, right? Say for example 5, your error is a function initially, now it drops down to 5 or 10, some numerical value, right? Only if you differentiate that value, it will be made equal to 0. What is differentiation of a constant? 5, 0. That's why we make use of differentiation everywhere when you go for your deep learning concepts, right? Maybe some more time would have been better for me, but maybe you can check this and later let me know. So this is the complete architecture which I want to give you. Kindly remember that CNN is not anything new. It is the process of same process, the block diagram which I showed you, feature extraction and again classification. But the only difference is feature extraction is automatically done by the network itself in the guise of convolution and downsampling or your max pooling. Features are extracted, again we go to the normal process of classification. That's why I have given represented in terms of a blue color box and a red color box. Again, we have many combinations, many softwares are available. MATLAB is available, Python is available, R language is available. Depending upon your efficiency or depending upon your expertise, you can use anything. I have worked with MATLAB and also with Python. So I think anything is okay for me. But suppose if you have already known Python, MATLAB only, you can still do your process with that. One of my scholar has done only with MATLAB toolbox, right? I think it is a 2018 version. Right? I'm sure it is a 2018 version. But if you know Python, I will advise you to go for Python because it is more user friendly when you go for multiple layers. Requirements, a high-end processor is very good. If you have a higher specification, it is very good, but you must have a sufficient bank balance for getting a good system also, right? If your university provides that, very good. But otherwise, some of my scholars are only using their laptop to get some of the results. So it depends upon you. Now we go into the last session of our part of our topic, transfer learning. Right? One drawback I told you in CNN, I'm not sure whether you have observed that or not. How many convolution layers should I have? How many normal max pooling layers I should have is still a problem, right? And the second problem is the computational complexity. I need to adjust the parameters of the filters and also I need to adjust the parameters of the normal fully connected layer weights. Can I make it more simple? Can I fix the number of convolution layers? Can I adjust only one weights instead of going for filters and the normal weights, right? The answer is transfer learning. First, we will see what do you mean by transfer learning. Then I will associate transfer learning with the CNN process. Human beings always have the capability of transferring knowledge from one task to one domain. Say, for example, if you know cycle riding, you will learn how to drive a car. Right? If you know cycle riding, you will learn how to drive a car. That doesn't mean exactly that both are same, but you are transferring some knowledge. What knowledge? You know, you have to apply the brake to stop the vehicle, right? You know when to turn, how to accelerate, right? So this knowledge you know because you have already used the cycle with you. So when you go for a car, the process may be easy. You can take some knowledge, some previous experience from the previous action and pass on to the next action, right? Now, if you take this statement, riding is a word, or maybe you can say drive a car. Driving and riding both are same, which corresponds to the same task. The task is going to be same. The work is going to be same. But what about the domain? The database, they are different. One is cycle and non-motorized vehicle, and the other one is car, which is a motorized vehicle. So what actually you are doing? You are doing the same task, but you are transferring some knowledge from the first task on a domain to another task on the another domain. Based on the task and domain, you can have 4 possibilities. Same task, same domain, same task, different domain, different task, same domain, different task, different domain. Option B and C is the important one, because same task, same domain, anyone will do, right? There is no necessity for transferring more knowledge. Say, for example, I am writing an English essay. I am writing an English poem. If I know English, writing an English essay, there will not be big deal in writing an English poem, right? Or when you take the last option, different task, different domain, there is no necessity for transfer of knowledge because both are different. The important one is same task, different domain, and different task, same domain, right? Classification of brain images and classification of lung images. Same task, different domain, or classification of brain images, segmentation of brain images, same domain, different task, right? So what I'm trying to say is, if I know classification of brain images, I can easily, underline the word easily, I can easily do classification of my lung image, because I can derive some experience from the previous process which is close to this process. This is what transfer learning is going to do. Maybe this is an example. I can skip this, right? How can we do this? How can we do this? Right, so look at the diagram on my left hand side, where you can find that 2 data sets are available, data set 1 and data set 2. Say, for example, data set 1 is brain image, data set 2 is lung image, right? But when you go for the classification and segmentation process, or any process, you need a large amount of database. That's what you would have heard if you're using deep learning. Deep learning, go for large amount of database, right? So without large amount of database, you may not be able to do the process with CNN, right? But when you go for the diagram on my right hand side, you can see that my data set 1 is brain image, data set 2 is lung image, but the size of the data set 2 is less. That means because brain image and lung image comes under the same category, I am going to derive some knowledge from the classification process of brain and apply it to my second process, so that I can easily do that even though I have a less amount of data set. This is all about transfer learning. Now the question you must answer is, what knowledge? I'm talking theoretically. Knowledge. Practically, what is that knowledge? That knowledge is nothing but the filter parameters. The filter parameters. I told you in CNN, we have filter parameters to be adjusted, and also the fully connected layer weights to be adjusted. But if these filter parameters are fixed, what are these filter parameters? They are feature extraction process. That means they are the features. If these features are fixed, then it will be easy for me to adjust only the fully connected layer weights. Why these features are fixed? I have an assumption that the features of the brain image will be almost, not exactly, almost equal to the features of the lung image. Right? So I need not train my filter parameters. The convolution layers can be fixed. Only the fully connected layer has to be adjusted. But we have a condition here. What is that condition? You cannot use example, if you're using a brain image, you cannot use a model which has been already trained with aeroplane image. Aeroplane is completely different from your brain image. Aeroplane will have sharp edges, right? Wings and something like that. But when you go for your brain image, it is oval. It is a soft tissue type. So always make sure that when you go for transfer learning, many pre-trained models are available. The fixed parameter models are available. Check whether your image has been already trained with or not, or at least some similar images have been trained or not. If that is the case, you can go for transfer learning. This is the place, again, the scholars make many mistakes. They take some models, some random models, which is available in Python and MATLAB, and they may use for an application for which completely it will not suit. Then how will you get an answer? Your feature extraction is wrong. When your feature extraction is wrong, your complete process will be wrong. Based on this concept, we have many pre-trained models available. If you are using, you must be knowing about this: BGG16, BGG19, Inception V3, Exception ResNet 50, and so on. If you take VGG16, what is VGG16? That 16 numbers corresponds to the number of layers. It is already fixed. The convolution layers are fixed. The pooling layers are fixed. You cannot change this. You can just drop down from the menu, click that, and you cannot change this. But if you go for a normal CNN, you can change this, but the complexity will be huge, and you will not know how many convolution layers I should use and how many pooling layers I should do. Dense layers corresponds to the hidden layer in the fully connected network. Right? So based on the experience, if you are choosing the correct pre-trained model, then the chance of your accuracy getting high is more than a normal custom. We have other models also. You can browse that. You will get lots and lots of information. So I'll come to this in the last. Now I'll show you a small application quickly in another 5 minutes. This is some of the work which we have done. Image database on COVID-19, right? Which is very, very important in the current situation. We have a database available for it. You can go there, you can download the images. Plenty of images are available. This I have downloaded maybe 3 months back, but I'm sure now the number of images would have tremendously increased with the rise in the number of cases. We have both CT and X-ray, so it is suitable for transfer learning based approaches. It's available in DICOM format. You can easily download it. And this is the way how it will look like. Your COVID-19, your pneumonia, SARS image, everything looks similar. If I don't give the name below, definitely you will not be able to identify which one corresponds to which. So complex situations. Don't think now the people are moving towards deep learning, so I also will go to deep learning. Check your application. If your application is complex, then go for deep learning. What do you mean by complex? It will have close similarities. Don't go for differentiation of aeroplane and a tiger using deep learning. Your normal neural network can do. Then why you want to make your system complex? Right? So choose wisely. So this is the architecture. We have used VGG16 and Inception V2. So once we fix the model, now you can specify the parameters. Always in the research paper, when you write a research paper, try to give the experimental setup and the variables or the parameters also. It will give a good impression in the sight of the editors and the reviewers. And this is what this one slide will comprise all the information which I have told you earlier, right? This is a skeleton taken from the Python language, where first the line is equal to model is equal to sequential, in the sense that one line will be executed after another thing. This is called as a library in which all the inbuilt commands are available. So it will be easy for you to execute. The second line says you are going to form the architecture, and you can add model.add is the syntax for it. And the inbuilt command is convolution 2D. If you use the convolution 2D operation, it will automatically create a convolution. What are the inputs necessary for the layer? Number of filters and the size of the filters. If you choose number of filters is equal to 2, you need to give the kernel size of 0, the first filter dimension, and also the second filter dimension. Border mode is called as the overlapping process. See, say for example, you have a 2x2 filter size matrix, and your original image is 3x3. Say for example, so how many pixels? 9 there. You have 4 here. How 4 will be exactly overlapped with 9? It is not possible. One column or one row will be missing. So there are many options by which you can append zeros on both sides, and still you can get the overlapping option or overlapping. But when you choose valid, The border mode is equal to valid. It will leave the remaining columns and rows as such. So it is just an option. You can choose other options also. Input shape, your input data you have to give with the help of the batch size. Batch size corresponds to how many images the process is taking at a stretch. If you have 200 training images, it may take 50, 50, 50 if you specify 50 here. If you specify 30, it will take 30, 30, 30. Sometimes again the problem is if you take 30, 30, 30, again 200 is not divisible by 30. So it will accept 30 or it will show some error. So it will be always better to use none. If you specify batch size as none, then adaptively, dynamically, the system will take the. Then you have the row size, then you have the column size, then you have the depth. If it's a color image, you will have 3 operations for the same filter for R, G, and B. Again, if it is a gray level image, it will be easy. You will have only one. Then if you have any negative values, it will be removed in the rectified linear unit layer. Again, I'm going for one more convolution layers where specifying the number of filters and the kernel size. And then again, max pooling. This is a random custom based model. So I am using my own number of convolution layers and max pooling layers. Dropout is an important concept which is used for avoiding overfitting. Overfitting means learning more. Learning more is also not good for any process. What do you mean by learning more? See, remember in deep learning, you are going to give the complete image as input, right? But the region of interest is somewhere inside the image. You are not going to tell the CNN that this is region of interest, this is not region of interest. So when the image, when the system tries to grasp information on its own, there is a chance that it will also learn the non-region of interest, which for us is considered as a noise. So what we do is we think that some of the neurons would have overlearned and got information about the background which is not necessary for me. So I will remove some of the neurons when I go for the hidden layers. If it is 0.25, among that 1:4 neuron will be removed. And flatten layer is the interface between max pooling and your fully connected network where 2D data is converted into 1D data. Then you have a dense layer which corresponds to the hidden layers in the fully connected network. And 128 corresponds to the number of neurons used there. Then again you have dropout. And the last one, dense number of classes, is the output layer. Number of classes corresponds to the application you have. Say for example, if you have digit recognition, it may be 10 because you may have numbers from 0 to 9, and also you can have a softmax activation function in the output layer. So for this activation function, you must have a prerequisite on artificial neural network. We have sigmoid, tanh, tangential hyperbolic function, threshold function, many functions are available. So you must have an idea on that. Now I gave you many mathematical equations, but interestingly or really funny to see that optimizer, the command, red color command optimizer is called ADA delta, will do the complete mathematical process. That's why people do not put their head into that mathematical stuffs. Again, all the blue color indicates that there are many options. ADA delta algorithm is there, ADAM algorithm is there, many algorithms are available. Then you, instead of your error, I have chosen the cross entropy to the objective function, and you can get your metrics, which is accuracy, sensitivity, specificity. Everything will be given from the software. Of the performance measures which you can get, and these are some of the values which you can get, and your values should be always logically correct, right? Normal versus COVID-19 value should be higher than pneumonia versus COVID-19. Why? This is what you should write in your research paper, right? Because normal and COVID-19 are sufficiently different. Normal, you do not have any white patches, that's fine. But when you go for pneumonia and COVID-19, that is the complexity. So definitely your machine also will have a low effect in that. So then logically your answer is correct. You cannot write a program and tell that milk is black. Right? Nowhere in the world is you can find black color milk. Just because it comes from buffalo, whose skin is also black in color, you cannot say milk is black in color. So don't fully trust on your programming language. Analyze your results. Check whether it is logically correct. And these are some of the things which you can get from your software itself. This is another database where you can find some different types of information, right? Just go to this database, you can find it. This is a custom based model developed by us. So we chose our number of convolution layers and max pooling layers. The results Python will give everything, right? But your duty is how to analyze and interpret the results, experimental results and discussions. That should be the heading, the last heading of your research paper. And discussion is what very, very important rather than just tabulating the results and showing some plots. I will just go to the some research problems, maybe. Yeah, these are some of the research problems. Can you find something equivalent to convolution for feature extraction? One person thought, okay, convolution can be replaced. Feature extraction can be replaced with the help of convolution. Can you think of some other mathematical process or contents which you have studied to replace feature extraction? How do you fix the number of layers in custom model? If it's a predefined model, fine, it is fixed, no problem. But if you are using custom model, can you at least generalize for medical applications, so and so, for remote sensing, so and so? Can we do that? When executing more images, what happens to computational complexity? Nobody in Earth talk about the complexity of deep learning. They give more importance to accuracy. But can we do something on complexity also? So nowadays there is another type of machine learning coming up called as quantum machine learning, right? To make sure that it is still practically feasible. What is your contribution in the model? Try to develop something on your own, right? I told you feature extraction is done by convolution layer. So stop with the convolution layer of CNN, take another SVM or any method, make a hybrid method. That may be your contribution. Is an accuracy of 100% possible. Most of the time we see in the research paper giving 100% result. Nowhere on earth anybody going to believe that. Maybe the number of data you have used is very less. Take the running race. Yes, a child may say I came first in the running race, right? But if you ask him how many people ran the race, he or she may say 2. All right, so that is not valid. You have to test with sufficient amount of images and then come to a conclusion. Only then you can say that your result is fine. So 100% result is very, very tough and practically impossible. And journal community may not accept that unless otherwise you prove it in an exhaustive way. So this is what I want to show you. We got some results with 111 precision recall, 100%, right? But again, it is not possible. Again, we refined that and gave a different answer. Some mistakes were there logically, right? Just to show that you should not do that, I'm giving you this result tab in the form of tabulation also. So that's what I want to tell you. Maybe I am correct me 5 minutes late. You can see the special issue. This is one of my special issue which is opened up. Uh, the deadline is February 2021, and the topic should be with deep learning and transfer learning, and specifically only for medical images. Right? Maybe you can check some of my papers in the Google. You may get some idea other than medical images also. But for this issue, it is only all about medical images. The impact factor is 1.77, and I am the lead guest editor, and the expectation will be two things, right? There should not be any plagiarism. It should be less than 20%, and some of the contents at least should be from deep learning, not from any other machine learning approaches. Thank you for your patience listening. I hope I gave you at least few information which you can take forward in your research career if you are working with CNN and other related deep learning process. This is my email, this is my WhatsApp number, and this is my web page, and I think it is under construction now. These are some of the edited books. Maybe you will get some idea on that also. At any point of time, if you feel like you need to contact me for any queries or something, you can always feel free to do that. Thank you for your patience listening. Academicians, they are very good in teaching, but listening is the most difficult part. But I hope you would have enjoyed it. Now, very quickly, we can go for some question answer session. If you have any questions, you can feel free to ask me. Maybe 5 minutes we can take, madam.
Yes, sir. Uh, Participants, if you have any questions, kindly unmute yourself and ask.
Thank you, Usha. What are the common data structures used in data deep learning? Are you talking about the models? I think you are talking about the models, data structures, or the architectures, right? When you take deep learning, it depends upon the application, right? Whatever I have shown now, CNN, DeepNet, ImageNet, ResNet, UNet, MobileNet, everything is used for computer vision group, people who are working with images, right? Suppose if you are working with text data, then there are other set of deep learning models like Stanford NLP, transformer, BERT algorithm, BERT. These are used for text. If you use signal, then you can go for LSTM, then you can go for 1D CNN is also there. You can make use of that. Suppose if you feel that I'm not using any of these things, I want something else, then also you can go for auto encoders is there, deep belief networks are there, which are normally used for dimensionality reduction applications, right? So reducing an infinite data to a smaller size, you can make use of that, right? Plenty of models are available based on the nature of data. Don't worry about the application. Nature of the data, you need to choose your method. Thanks, Dr. Sumati. Thanks, Anbu Selvi. I will ask the coordinator, Dr. Brindha, to hand over the video recording to you, so that when you look at the PowerPoint along with my voice, maybe you will get a better idea on what I am trying to say.
Sir,
Thanks, Rajneesh. Yes, madam. Yes, continue.
I have one question. How do you find time to do all the work, sir? How you are managing your time schedule?
Okay,
Time for
just a
break.
minute. I will share my last slide. One person has asked. Madam, is my last slide visible?
Yes, sir. Visible.
Okay, you can take my information. So if you ask me how I am going to find time, so definitely there is a gender bias, I should say. My wife is also an associate professor, but the level of work she can put is not that much in comparison to me. Right? The first one you need to have is the interest towards doing something. Normally, what I do is I never do anything at a stretch, right? I will do only bit by bit. Say, for example, every day I used to spend 45 minutes or 1 hour. During my early career, I go for sitting for maybe 2 hours to 2.5 hours every day, right? But that may not be easy for all. Later in the night, somewhere in the evening, I sit. But nowadays, it is sufficient for me to sit for 45 minutes or 1 hour to do some process. And more importantly, I make use of the time between two theory classes, right? I am also an associate professor where I have two theories, two labs to handle, and then NBA is there, NAC is there, everything is there. It's like a common thing, right? So what I used to do is whenever I get time between two classes, right, I just try to make sure that I do something on that. Maybe I will type the title alone. I just think about the title of my research paper, type the title alone, or I will write the abstract alone, or I will do a 3-line coding. That is sufficient. That will give you more confidence. Right? That I will then close the laptop. Then next day I will open it up again, take the result and do some process. Every day you can, if you do some process, definitely you are going to get something out of it in the next day. Can't you write everything in a, can't you write at least 10 lines in a MS Word file every day? I think everybody can do just 10 lines in an MS Word file. Everybody can do, but maybe we are not getting an interest or something towards that. We are not doing that, right? But once your mindset changes, your attitude changes, definitely you can also do all these things, right? Initially, nobody will come to you for collaboration, right? They will look for your expertise. So you should individually do some works and show to the world that you know something. Once you do that in the form of a publication or something like that, then other team members will come to, hey Jude, can you come and join with us? Then your workload will be easy, right? 50% you can do, 50% other people will do. That's the way how you have to grow. That is the most important thing. Attending workshops and conferences, try to find some fellow network people who is doing work with like US, right? Try to have their contact, have some collaborative network. That is very, very important. Otherwise, you can never ever do anything in the research arena.
Thank you, sir. Thank you very
Thank
much.
you, thank you.
Thank you very much. Participants, any other questions?
Thank you all. Thank you, Dr. Sumati. Dr. Shobha, definitely the organizer will give you the video, I think. Thank you, Shobha.
Okay.
Okay.
I'll conclude the session. Thank you,
Okay.
sir. Today you have motivated all the participants to update their research skills every day, every month, every year. Like you mentioned in the first slide, we will try to follow your ideas, sir, to achieve our goals in research and
Sure.
publication. You are one of the role model, best role model for all the teaching fraternity,
Thank you.
and
Thank you.
uh, we will try to follow your ideas, sir.
Thank you.
Thank you, sir.
Thank
Thank you very
you.
much.
Okay. Thank you. Thank you.
Participants, again, you can join for the next session by 11:30.